Hey there, Mr. Sutton here, bringing you the Pre-Cal Honors 6-2 Part 1 homework solutions on vectors. For this problem, we're trying to find the component form of a to b and also the magnitude or absolute value. For component form, we're essentially just doing b minus a to get directions from one to the other. So we'll do the x's first, -2 minus -1 or -2 plus 1. And then we have the y's, 5 minus 7, with a comma separating all this. So that gives us -1, comma, -2. Next, for the magnitude, we just have to use Pythagorean theorem on this to find the length of it. So that's going to be the square root of -1 squared plus -2 squared. So we've got essentially 1 plus 4, or 5, inside the radical, and we can't simplify that anymore. To find the component form of the vector from a to b, we need to do b minus a. So do the x values and y values separately. We've got -5 minus 6 for the x values, and -2 minus -4 or plus 4 for the y values. So that's going to give us -11, comma, 2. And then to find the magnitude, the absolute value, we just need the length of this thing. So we'll use Pythagorean theorem here. Square root of -11 squared plus 2 squared. So that's 121 plus 4, which is 125. And I can split this up into radical 25 and radical 5. So 5 root 5, our final simplified answer for this one. For this problem, to do 9 times u, let's start by replacing u with our component form here. So 9 times -20, comma, -21. Now I just have to distribute the 9 to each of these. So we've got -180, comma, -189. For this problem, I'm essentially trying to divide the v vector by -2. So let me write this as -8, comma, 4 over -2. And now I'll just divide each of these individually by -2, giving me the vector +4, comma, -2. On this problem, to do u minus v for these vectors, let me replace these variables with the component forms. So we've got -9, comma, 7 minus -11, comma, 9. And now I'll just subtract the x's and the y's separately. So we've got -9 minus -11, or -9 plus 11, comma, 7 minus 9. That gives us 2, comma, -2 for our answer. For this problem, to do 2u plus 2v, I'm going to replace these variables with the component forms. So I'm going to write 2 times -6, comma, -3, plus 2 times 4, comma, 6. Now let's do a little PEMDAS. We're going to distribute first, and then we'll add the vectors together. So distributing these 2's, we've got -12, comma, -6, plus distributing the 2 over here, this is going to be 8, comma, 12. Let me just add the x's and the y's separately now. So we have -12 plus 8 and -6 plus 12, giving us a final answer of -4, comma, 6. On this problem, to do -9u plus 7v for these vectors, let's replace the letters with the component forms. So I've got -9 times -1, comma, 7, plus 7 times 1, comma, -1. Let's distribute, and then we'll add whatever's left over together. So distributing this first one, I've got 9, comma, -63, plus distributing the 7, we've got 7, comma, -7. Now I'm going to add the x's and the y's separately. So I've got 9 plus 7, comma, -63 plus -7, or -7. So adding all that up, we've got 16 for the x, comma, -70 for the y. For this problem, I need absolute value of v minus 4w. Let me start by plugging in the component forms here. So this is going to be absolute value of -8, comma, 4 minus 4 times -6, comma, -2. I have to do everything inside the absolute value before I apply the magnitude here. So I'm going to do this -4 times next. So distributing the 4, we've got, I'm going to keep the minus here. So this is going to be -24, comma, -8 inside. Now I'm going to go ahead and subtract these vectors. So that's going to be -8 minus -24, or plus 24, comma, 4 plus 8. So inside my absolute value when the dust settles, I've got a 16 and a 12. Now I'm going to go ahead and use Pythagorean theorem on these to find the length, the magnitude. So this is square root of 16 squared plus 12 squared. This is 256 plus 144 for a grand total of 400, and the square root of that is 20. Or you might have recognized that this was a 3, 4, 5 kind of triangle. To find the dot product of these two vectors, I need to multiply my x's, negative 9 times negative 6, plus my y's multiplied, so negative 2 times negative 1. And then let's just simplify this. So I've got 54 plus 2, which gives me 56. To find the dot product of these vectors, I multiply my x's and y's separately and then add the products. So I've got negative 6 times 4 plus 7 times 8. So this is negative 24 plus 56, giving me 32.